गुड मॉर्निंग एवरीबॉडी। माई सेल्फ आचार्य विश्वेंद्र आज इक्विलिब्रियम पे आपसे बात करूंगा। आइए स्टार्ट करते हैं। सो द टॉपिक ऑफ टुडेज डिस्कशन इज इक्विलिब्रियम। इक्विलिब्रियम को हम तीन तरीके से कैटेगराइज कर सकते हैं: स्टेबल, अनस्टेबल एंड न्यूट्रल। इक्विलिब्रियम का कॉन्सेप्ट समझने के लिए आप एक चीज सोचें, फोर्सेस के बारे में थोड़ा सा सोचें कि वाई फोर्सेस एक्ट्स, why two bodies apply forces on each other, and what is the impact of force. Force will certainly lead to reduction in energy. If you analyze yourself, just think, what is impact of force? When you apply force on something, when you do something, why you are all doing this? So there is only one reason of working or applying force, and that is to lose your energy. Just take the example of a student. He is involved in certain kind of action. He's doing something, either he's doing something physically, or he's thinking, or he's doing something at the mental level, but everybody is trapped in a matrix in which you are forced to do something, forced to work, so that the energy that you consume from the food is just to do work. So life is like that. Till the moment you are born and till you die, you will have to work by hook or by crook. Situations of life will force you, will stimulate you, or will supply you energy to do work. So as simple as that, just observe the energies within you. There is something within you which is trying to dissipate its energy, trying to lose its energy, so that ultimately it gets tired and it goes to sleep, or it just wants to take rest. Take example of any human being. When you rise early, then you have a lot of energy, and you need to use that energy for doing various works. And at the night, when you are tired, you have lost all your energy, you need to sleep. When you sleep, something happens within you and you get certain sort of energy which is needed to do daily tasks. So that fundamental energy which is needed to perform daily tasks is the purpose of life. So life is just about getting energy from somewhere. When we sleep, utilize that energy in doing a daily work, and accepting food, and gain energy in a form which is used in doing mechanical work. That is a different sort of energy. Mental energy, the energy which you gain when you sleep, that is a different sort of energy, different form of energy. So ultimately, if you observe life, the entire universe is nothing but a transition of energy. Universe is composed of billions and trillions and septillions of atoms working under the influence of energy, trying to lower their energy and getting into more stable states. That explains the entire philosophy of life. So equilibrium is the factor, the concept, the topic which deals with why somebody is working, why there is a force inside you which stimulates you to work in a certain way, and where it leads you. What happens when you do some work? Where you go when you sleep, and why you need to sleep at all, from where you get the energy, and how that energy is utilized in your daily work. So all these answers lies in the concept of equilibrium in physics. So equilibrium is about when force on a system is zero, dealing with the one particle system. If the force on the particle is zero, then we said that this particular particle is in equilibrium. So force is zero means he has he is not active at all. He don't have a force, so he will not be able to change the state of motion. If he is at rest, he will be at rest as per Newton's laws of inertia. And if he is moving, he will continue to move with that uniform velocity. There will be no change in his state of motion. So to bring that change, a force is needed. And equilibrium states refer to the position when that tendency to change is not there. So that refers to the equilibrium state when there is no tendency to change. Then comes non-equilibrium states when there is a tendency to change. And if observed at cosmic level, at the level of the cosmos, we can say that there is a concept of creation and destruction. Creation is when there is a force to in a state of in a non-equilibrium state, and destruction, or you say that the zero or the parbrahma is there when there is no tendency to apply the force or to change. So forces in nature has a lot of things to do with the creation itself. So if you observe the entire creation, everything is in motion, forces are being applied, everything wants to do this and that, everything wants to change itself. And that change is often described in terms of the forces. So ultimately, equilibrium refers to the position when there is no tendency to apply the force. The force vanishes. The quest inside you to change vanishes for a particular moment. But if you change the space and time, the tendencies may change, forces may act. So at all, equilibrium is about the energies and the forces, how they interact, what are the concepts that I have already discussed. So take example of any system, one particle system. If there is a force on it, we say it is a non-equilibrium state. It has a tendency to move to some other place. For example, take example of your mind. Your mind wants to take you to somewhere beyond the present. It's either busy in contemplating past or busy in either visualizing the future. So mind is such entity which is not at present, which is always away from what is truth, what is present. So there are forces on it. So they try to disturbs you, or disturbance itself is the source of change. Things changes, the entire universe is changing because there is a certain dynamic factor which wants to change things, which don't let them to move in the specific way. So the same thing here is the concept of force and equilibrium. So equilibrium in a nutshell is the point at which force on a body becomes zero at that specific space and time. But if you switch the positions, if you switch back, if you move the space-time curve, tendencies may change, and what we refer to as the non-equilibrium states. So this was the concept of equilibrium. Let's discuss some mathematical analysis of the states of equilibrium. So equilibrium can be stable equilibrium, the unstable, and the neutral. In all the three equilibrium, force or the first derivative of potential energy with respect to position is zero in all the cases. Whether it's a stable equilibrium, whether it's unstable equilibrium, or whether it's neutral equilibrium. In all the cases, force has to be zero, or the single derivative of position, potential energy with respect to position is zero. The first thing. Second thing is, in stable equilibrium, potential energy is minimum. So you become stable when you don't have energy. So stability means you don't have energy because energy is needed to change. So when your energy is minimum, you are highly stable. And you must have seen that everybody want to be stable. And for that, you don't need to have energy. That state is achieved when you don't have energy. So it's very hard to get rid of the energy because energy is itself the life. Life is nothing but a process of energy transformation from one form to another. And if you don't have energy, then there is the concept of force over here. So, in case of stable equilibrium, potential energy is minimum. For unstable equilibrium, it is maximum. And for neutral equilibrium, potential energy is constant. So, just see things within you. When you have minimum energy, you are highly stable. Internally, you feel like doing nothing. You are the entire creation yourself. That is when you become unstable. But when you are highly unstable, you have highest form of energy, you are highly unstable, you will be highly reactive, you will feel like doing this, that, and things like that. Forces will act within you. And when your energies are constant, potential energy is constant, also when you don't have any tendency, no force will act on you. But that shows that with respect to space and time, your potential energy has become constant. So it's neither creation nor the destruction. It's like being omnipresent, being resonant with the absolute zero. So this is how things can be realized. Now, third important point is that for stable equilibrium, double derivative of position, potential energy with respect to position, this is positive. For unstable equilibrium, this is negative, and for neutral equilibrium, this is zero. Fourth point is if you calculate dF by dr, the derivative of force with respect to the position. So del square u by del r square is nothing but minus of dF by dr. So in case of stable equilibrium, the first derivative of force with respect to position is negative, and which is also equals to tan theta. So we can say that theta in this case will be obvious. As you can see over here in this diagram, here theta is greater than 90 or it is obvious. So you can observe it from here. Next point is in case of unstable equilibrium, dF by dr is positive. So derivative of force with respect to position is positive for this case. And for neutral equilibrium, dF by dr is 0. So the first derivative of force with respect to position is 0 in case of neutral equilibrium. From the graphs, you can see that FR graph is like shown in the figure. So there are 2 points, point A and point B. At both the points, force is 0. And we can say that at A, theta is obtuse, so it corresponds to equilibrium position. And if we analyze closely, take the example of a bowl. You put a sphere over here, and if you release it from rest, it will have a tendency to always move towards this point, which is the equilibrium point for this. So if the sphere is here, it will have a force which is directed towards equilibrium position. If you move it here, then also it will have a force directed towards the mean position. So there is a force, net force, which directs the particle to move to the equilibrium position. If such a force exists, then such an equilibrium is called stable equilibrium position. Then such a force is called, such a equilibrium is called stable equilibrium position. While if we see, there is a inverted bowl line, and if you release the point over here, the particle over here, and if you shift it, then it has no tendency. It has a tendency to move from away from the equilibrium position. You can say that when you displace it from this position, it has a tendency to move away from the equilibrium position. Then it is called unstable equilibrium. And the third is a neutral equilibrium. When dF by dr is equals to 0, there is no tendency to move towards the equilibrium position. Then the equilibrium is called the neutral equilibrium, or there is you can say that no force on the body. So it's just shown in the graph over here. So these were the three types of equilibrium. I have discussed the concepts. That equilibrium is when there is no force. And this condition can be envisioned in terms of three aspects: stable equilibrium, unstable equilibrium, and neutral equilibrium. In a stable equilibrium, potential energy is maximum. So in a stable equilibrium, potential energy is minimum, slip of time. In unstable equilibrium, potential energy is maximum. And in neutral equilibrium position, potential energy is constant. So from stable, unstable, and constant, I mean when you move away from the equilibrium states, away from the special positions where equilibrium is there, then if potential energy at a certain point is found to be maximum, when you move, when you change the position or when you change the, then when potential energy is maximum, then that is the state of unstable equilibrium. It has got maximum potential energy as compared to its neighborhood. Similarly, when the potential energy is minimum, it is called the stable equilibrium position. So it has got minimum potential energy in its neighborhood. And when the potential energy becomes constant, it is called the neutral. So this is how equilibrium are defined. Now let's deal with one question. Suppose here ux graph and fx graph is given, and there are certain points a, b, c, d, e, and a dash, b dash, c dash. Now the question is which point corresponds to stable equilibrium. So you can see that stable equilibrium means potential energy is minimum. So it corresponds to point C. and also corresponds to point A dash, because this is the UX graph, potential energy position graph, and this is the force X graph. And at A dash, you can see that force is 0, and this angle is obtuse. So as done over here in the very first case, so it is the same situation over here. So we can say that at C as well as A dash, equilibrium will be stable. Then unstable equilibrium, so unstable equilibrium will be at A, E. And obviously here at C dash, because here also force is 0. So equilibrium condition is also satisfied over here. Then we have neutral equilibrium. So neutral equilibrium is here, this line is perfectly horizontal, so potential energy is constant over here. So we can say that at F there will be neutral equilibrium. Then is non-equilibrium. So non-equilibrium is when potential energy is neither maximum nor minimum. So it corresponds to the point B and B. Then is the question that under what condition use maximum? So use maximum at B. And here the next question is what about B dash? So you can see at B dash df by dx is 0, which means del square u by del x square is 0. So will it be stable equilibrium, unstable equilibrium, or neutral equilibrium, or non-equilibrium? So thing is non-equilibrium, because force is equal to 0 is the first condition. Double derivative conditions comes later. So B dash is a non-equilibrium state. So in this way we have seen, we have complete the entire concept of equilibrium. The first thing, how to visualize that, how to feel that out, and what is the mathematical implication of this and its implementation in the question. So as per my videos are concerned, I will make sure that whatever topic I discuss, the first thing is to make you physically feel that thing, which is called the concept of a particular topic. After relating the concept, after understanding the concept, concept means when you have to go through a thinking process, you understand things, you try to make mind maps, and when you come to know that, oh, this is the thing, when your neural cells starts acting on what you are being taught, what you are actually learning. So after that is the time for the mathematical analysis, the results, and then is the time of the questions. So everything that you learn starts from a simple conceptual discussion that stimulates your mind-brain system to learn new things, followed by the mathematical equations, the technicalities, the facts, the laws, and at the last, implementation of what we have learned through the question answer and its discussion. So this is how you should proceed for learning things effectively, and which is the basis of cracking competitive exams like the uni. So if you have any doubt, you can ask in the comment section. Thank you and have a nice day.